The binomial theorem is going to allow us to expand a binomial, for example, x plus y, to any exponent, say to the third. In order to use the binomial theorem, we need to bring in Pascal's triangle. Pascal's triangle is named after Blaise Pascal, a French mathematician. And what he discovered was that if he placed a 1 and then 2 ones below that to form a triangle, to get the next row, he took another 1, added the 2 numbers above, placed that 2, so 1 plus 2 gives us 2, and end it with a 1. Notice the triangle formation. Notice 1 plus 1 gives us 2. To continue this pattern, we have 1 plus 2 gives us 3, 2 plus 1 gives us 3, and we end with a 1. Our next row, 1, 4, 3 plus 3 gives us 6, 4, 1. And finally, one more row, 1 plus 4 gives us 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and our 1. This pattern continues forever. To name these rows, we start out with row 0. The second row is actually called row 1. The third row is called row 2, so on and so forth. So our final row here would be called row 5. We name this row 5 because if you look at our exponent, that's going to tell us what row we're going to look at. Notice we have an exponent of 3, so we're going to come to the third row, which is nicely named with that 3 in the second place. In order to expand x plus y to the third using Pascal's triangle, we're going to begin by looking at what x plus y would look like just written out. We have x plus y times x plus y times x plus y. Remember, when we multiply out binomials, we multiply the first term to the first term, so that would have given us an x squared if I just looked at these two. Bring in my third one, I end with an x to the third. So looking at Pascal's triangle and these terms, we're going to start with a 1, which is the first number in our Pascal's triangle. We have x, multiplying those 3 x's together, give us x to the third. And then we have no y's in that first term. Plus, bring in our 3 from Pascal's triangle. Now we're going to take and decrease the exponent for our first term and increase the exponents for our second term. So 3x squared y to the first. Our next term will begin with 3 from Pascal's triangle, decreasing our x terms, so we have x to the first and y squared. And we're going to end with 1 y to the third. We have no x's, and our coefficient is 1. Cleaning this up, 1 x to the third y to the 0. Remember, y to the 0 is simply 1. So we have 1 times 1, which is 1 x to the third, plus 3x squared y, plus 3x y squared, plus y to the third. Notice in your exponents, in their expansion, they always add up to be 3. 3 plus 0 is 3, 2 plus 1 is 3, 1 plus 2, and then 3. And this will always be the case. Whatever your exponent is what these will add up to be. So let's go ahead and look at another expansion. Let's take a plus b. This time let's take it to the fourth. So I'm looking at the fourth row. I'm going to begin with a 1, which we really don't need to write. So we have 1a to the fourth, and no b's. Plus, we're going to decrease the exponent of a, and increase the exponent of b and bring in the coefficient from Pascal's triangle. Plus 6a squared b squared plus 4a b to the third plus b to the fourth. And there's your expanded answer. We could simplify this by taking out the 1, since it's understood to be 1, and there is your simplified form. It gets a little more tricky as we look at changing this plus sign to a minus sign. So let's take this a plus b to the fourth and change it to a minus b to the fourth. Again, we're still using the fourth row, so this is where our coefficients are going to come from. But let's look at see what happens as we take this negative through. We're going to still start with 1a to the fourth plus 4 from Pascal's triangle, a to the third, and now we have a negative b to the first. Plus, so that negative comes and follows along with that second term, plus 6a squared, then negative b to the second, plus 4a negative b to the third, plus 1 times negative b to the fourth. Simplifying, we have a to the fourth minus, because we have 4 times a negative b, a to the third b. Notice on our third term here, however, we have negative b squared. A negative times a negative is a positive, so it's actually going to cancel itself out, and we'll end up with 6a squared b squared. Here we have a negative b to the third, so we have 3 negatives multiplied together, which will give us a negative. So minus 4a b to the third. And our final term, we have a negative b to the fourth, so 4 negatives multiplied together will give us a positive b to the fourth. What I'd like to look at is our signs for each of these terms. Notice we start with a positive, goes negative, positive, negative, positive. The only difference you're going to see from example 2 to example 3 is that alteration between positive and negative. So a nice little shortcut, if you ever have a negative or a minus binomial, we can simply take and alter each of those signs, and we really don't need to worry about putting these in parentheses. It does get a little more complicated as we begin placing numbers into our binomial. So let's take example 4 and expand out, say, x plus 2, and let's go just to the third power. Again, we're using row 3 of Pascal's triangle. If you look back at your Pascal's triangle, that row is 1, 3, 3, 1. Remember, these are the coefficients of each of our terms in our expanded form. Beginning x to the third plus our coefficient 3 from Pascal's triangle. We're going to decrease the exponents of our first term and increase the exponents of the second term. So now we have 2 to the first plus 3 from our next term in Pascal's triangle, x times 2 to the second, plus 1 from Pascal's triangle, no x's, or x to the 0 if you wish, times 2 to the third. Again, notice all of my exponents are going to add up to be what my original exponent was. So 3, 2 plus 1 gives us 3. 1 plus 2 gives us 3, and 0 plus 3 gives us 3. Simplifying, we have x to the third plus 2 to the first times 3 gives us 6x squared. 3x to the first, 2 to the second, so we have 4 times 3 gives us 12. X plus x to the 0, remember, is 1. So we have 1 times 2 to the third, which is 8. And that's our expanded form. Finally, let's look at one more example, and let's take this x plus 2 and let's change that positive, and let's just look at what happens when it becomes a minus sign. Let's say x minus 2, and let's change the exponent. Let's leave the exponent the same, x minus 2 to the third. So again, we're still using 1, 3, 3, 1, our third row. But remember, from examples 2 and 3, we should be able to simply change every other of these signs. Let's look at that to make sure that it does happen for us. So we have x to the third plus 3 times x squared, and then negative 2 to the first, plus 3 x to the first times negative 2 to the second, plus 1 x to the 0 times negative 2 to the third. Simplifying, notice we have our x to the third. We have negative 2 to the first, which is negative 2, times 3 gives us negative 6x squared. Negative 2 times negative 2, or negative 2 squared, is 4, times 3 gives us 12x. And negative 2 to the third gives us negative 8. So notice we did start with a positive, went negative, positive, negative. Same way up here, same numbers, all positive since we started with an x plus 2. Here we alternated positive, negative, because we had that minus sign. In example 6, let's take a little more complicated problem. Let's say 2x plus y squared and take it out to the fourth power. Remember, we're looking at the fourth row of Pascal's triangle. So 1, 4, 6, 4, 1. And those are our coefficients to our expansion. We're going to begin by taking 2x. Now we're going to place the 2x in parentheses and take it to the fourth power. Plus 4 from our coefficient of Pascal's triangle times 2x to the third times y squared plus 6 times the quantity 2x squared and y squared squared. Notice again, our exponents are always adding up to being the exponent we started with, which is 4, plus 4 times 2x to the first and y squared to the third. Finally, y squared to the fourth. To expand this out, notice we have 2x in quantity to the fourth. So we take each of these to the fourth power. 2 to the fourth, remember, is 2 times 2 times 2 times 2, or 16 x to the fourth, plus 2 to the third gives us 8 times 2, which is 32 x to the third, and y squared to the first is simply y squared, plus 2 to the second gives us 4, so we have 6 times 4 is 24, x to the second, y, now we have y squared squared gives us y to the fourth, plus 2 to the first is 2 times 4 gives us 8x, y squared to the third, remember we're multiplying the exponents, so we get y to the sixth, And finally, y squared to the 4th gives us y to the 8th. Notice our exponents do not follow the same order as what they did before. That's because we're taking y squared and taking it to a higher exponent each time. And that concludes our binomial expansion.